Differentiation of trigonometric functions. At the end of this lesson, you must be able to determine the derivative of expressions involving trigonometric functions and express it in simplest form. Here are the trigonometric identities that are most commonly used to simplify expressions involving trigonometric functions. We have here the reciprocal identities, the sum and difference of two angles identities, the double angle identities, and the squared or the Pythagorean identities. Listed here are the differentiation formula for the trigonometric functions. If we have u a function of x, then the derivative of sine u with respect to x is equal to cosine u du dx. And that the derivative of cosine u with respect to x is given by negative sine u du dx. Now for tangent of u, the derivative with respect to x is secant squared u du dx, and that when we are to differentiate cotangent of u with respect to x, we will have for its derivative negative cosecant squared u du dx. And for secant of u, its derivative with respect to x is the product tangent u times secant u times du dx. And the derivative of cosecant u with respect to x is equal to cotangent u times cosecant u times du dx. Let us now apply these rules and find the derivative of each of the following functions and simplify the result. For number 1, we have y is equal to 2 times tangent of 1/2 x minus x. The form of the function y is a difference of two terms. We have the difference between 2 tangent of 1/2 x and x. So that if we are going to differentiate the function y, then we will be applying the rule to differentiate a difference. Hence, we have y prime equal to the derivative of 2 tangent of 1/2 x minus the derivative of x. In differentiating tangent of 1/2 x, we will be applying this rule to differentiate tangent of u, where the derivative of tangent u with respect to x is given by secant squared u times du dx. So that y prime now would be equal to 2 times the derivative of tangent 1/2 x, which is given by secant squared of 1/2 x times 1/2. 1/2 is the derivative of the angle 1/2 x. The second term, derivative of x with respect to x, would just be equal to 1. Multiplying 2 with this 1/2 would reduce the first term to just a secant squared of 1/2 x. And y prime would be equal to the difference between secant squared of 1/2 x and 1. Now we can simplify this particular expression for y prime, recalling that we have this identity. We have 1 plus tangent squared of theta is equal to secant squared of theta. So that secant squared of theta minus 1 would equal tangent squared of theta. So secant squared of 1/2 x minus 1 will just be written in terms of tangent squared of 1/2 x, making use of this identity. For a second example, we have y define the ratio of 4 cotangent x divided by 1 plus cotangent squared of x. Though it is possible to differentiate y as a ratio of these two expressions, however, in this particular example, what we will be showing is a solution that first simplifies the form of the function y. Recall that we have this identity. We have 1 plus cotangent squared of theta is equal to cosecant squared of theta. Applying this, the denominator 1 plus cotangent squared of theta can now be simplified to just cosecant squared of theta. And now express y equal to 4 cotangent of x divided by cosecant squared of x. Now, here we can express cotangent x and cosecant squared of x using cosine x and sine x functions. Replacing now cotangent of x by the ratio of cosine x divided by sine x, and the square of cosecant x can be expressed in terms of 1 divided by sine squared of x using the reciprocal identity. Okay, so for this complex fraction of cosine x divided by sine x all over 1 divided by sine squared x, we can now express this as a product of the numerator with the reciprocal of the denominator. So that y is now given by 4 times cosine x divided by sine x times sine squared of x. Now, one factor of sine x will be dividing out with this, so that y is now equal to 4 times cosine x times sine of x. But 4 can be expressed product of 2 times 2. Okay, so that y is now written equal to 2 times 2 cosine x sine of x. Now, we have this identity. We have 2 sine theta cosine theta equal to sine of 2 theta. So that this particular function y can now be simplified further to just a y equal to 2 sine of 2x. Now, having written y this way, it is easier to differentiate compared to differentiating a fraction. Okay, and in differentiating y defined equal to 2 sine of 2x, we will be making use of this rule, differentiating sine u with respect to x, giving us a cosine u du dx. So that y prime now, which is the derivative with respect to x of 2 sine of 2x, is given in terms of 2 times cosine of 2x times the derivative of 2x, which is just 2. And right now, y prime in terms of 4 cosine of 2x. Number 3 function is g of x is equal to e raised to sine of the square root of x. The form of the function is e to the u. Okay, so that if we are to differentiate an e to the u with respect to x, the derivative would just be equal to e to the u du dx. So for the function e to the sine of the square root of x, the derivative now would be given by e to the sine of the square root of x times the derivative of sine the square root of x, where the derivative of sine u is cosine u du. So we have here cosine of the square root of x times the derivative of the square root of x, which is just 1 over 2 the square root of x. Okay, so g prime here now is given by product of cosine the square root of x times e to the sine square root of x divided by 2 the square root of x. And if we are going to rationalize the square root of x factor in the denominator, then we multiply this fraction with the square root of x divided by the square root of x. Okay, simplifying now, g prime of x into the square root of x times cosine the square root of x times e to the sine square root of x divided by 2 times the product of these two factors, which is just an x. Now for number 4, h of x function given by cosine squared of 1 minus 2x cubed. The form of the function is a power function where we have the square of cosine 1 minus 2x cubed. So if we are going to differentiate the said function, we will be applying this rule to differentiate a u to the n, where the derivative is given by n u to the n minus 1 times du dx. Hence, h prime of x will now be given by 2, which is the exponent, times the base cosine of 1 minus 2x cubed, times the derivative of the base, which is negative sine of 1 minus 2x cubed, times the derivative of 1 minus 2x cubed given by negative 6x squared. From there, h prime of x will now be given in terms of, okay, we have 6x squared, writing it there, okay, times 2 cosine of 1 minus 2x cubed times sine of 1 minus 2x cubed. Now take note that negative 1 times negative 1 is positive 1. So h prime of x will just be equal to this product. But again, we recognize this particular product of 2 sine of 1 minus 2x cubed times cosine of 1 minus 2x cubed to fit the identity for sine of 2 theta in terms of 2 sine theta cosine theta. Hence, h prime of x now is given in terms of 6x squared times this expressed as sine of 2 times 1 minus 2x cubed. In summary, the differentiation rules for trigonometric functions are easy to use. However, in differentiating trigonometric functions, either we differentiate first the function and then simplify the results by applying appropriate trigonometric identities, or we can simplify first the given function by using applicable trigonometric identities before differentiating it.